Session 4, object literals. So an object, well, we're familiar with an object. It's a data type that holds key value pairs, where each key is what you're actually looking up, and the value is the result that comes out of it. But an object literal is a specific kind of object which has the idea that each key value pair is a property of something, or someone in this case. A person has a first name, a last name, an eye color, an age. Each property is an association with a name and a value. So you can represent nearly anything with an object. Person's a good example. You can think of a school. It has students, and they can have an array of student IDs. There's many different ways that one could structure them. Additionally, we've demonstrated that objects can have arrays, but they can also have other objects. They can have any value on this right-hand side in the key value pairing. So in object literals, keys and values do not just have to be strings. They can be other data types. Like here we have an example of an organization. It has a name like Code Platoon, that's a string. A type, which is nonprofit. It has topics, which is an array of strings. HTML, CSS, JavaScript, Python, soft skills. And then we have cohorts, and this is an object. And this object contains a key value pairing, 2020, and here we'd probably have an array of, maybe the students in that cohort, for example. All right. So there's two different ways that we can interact with an object literal. One is, here's an example of an object, Code Platoon, an organization that has the name Code Platoon. So we can access it with either a dot or a bracket. So I take the name of the object, organization, use a dot, then the name of the key I wish to access. And the result of this is going to be the value attributed to that key. Similarly, I could have a bracket and then put the name of the key in quotes. So this is called dot syntax and bracket syntax respectively. You will see both an awful lot. I usually prefer dot syntax because it's cleaner, but there are reasons to use bracket syntax where dot syntax won't work. For example, if you are looping over a list of some kind and you want to index with an iterator, you have to use bracket syntax, because otherwise it will assume that you're using the name of the iterator as the literal key that you are referring to within that object. So here's a simple example here. There's another way that you can actually check to make sure a key is in an object besides just saying, organization.name. What if it doesn't have name? Let's just check to make sure it's in there first. So there's something called the in keyword. The in keyword can be used to check if a certain key exists in an object. So here I have a key, name, and type. So that means the organization has the name key and the type key. If I asked for a key called students, and I say, is students in organization? It'd say, no, it's not. So here I can say name in organization. That's going to return true. So if true, console log true. So it's going to print true. But if it wasn't in there, this would return false. So the if statement wouldn't work, and then it'd go to the else and say console log false. Now, there's another way we can do it. There is a method that exists on all objects called the dot has own property method. And you can check for the name of the property, name in this case, using it. You'll more often see people using in because it's a lot cleaner, but they're both equally valid. All right, so there are built-in object methods. You can take the name of the object and dot has own property, like we just demonstrated here, to see if it has a name. And it returns either true or false if the key exists in the object. We can return an array of all the keys in the object. And actually, I feel this is one. I can go through an example for this one in particular. So let's Let me just open up a console real quick so I can show you what that would look like. Let's say I make up an object. I'm going to say my object equals A1, B2. And I could say A in my object, and that, oh, my bad. It has to be the string A in my object, because that's how we refer to keys. Otherwise, it's looking for a variable A, which doesn't exist. So A in my object, yes, it does exist. Is there a key C in my object? It's going to say, no, there isn't. Alternatively, I could say my object dot has own property. A. And that worked exactly the same way. If I gave it C, it wouldn't work. If I wanted to see all the keys in my object, you might think that I would say my obj dot keys. And let's see what happens if we do that. My object dot keys. It doesn't work. That's because this doesn't belong to the object itself, but rather to the object class. So if I say object dot keys, that is a function, and I can run it on the, and I can pass it the object that I want to check it in. And that gives me an array of all the keys in that object. Similarly, we also have dot values. So this is the notation you use to find the keys and the values of the object and return an array with those keys and values respectively. And you'll actually notice that I've used this before in our comparing objects to check if two objects are the same. We've used these object.keys and object.values before. There's also object.entries, which returns an array of key value pairings. So I can go in here and say object.entries on the object, my object. And here, the first entry is the key value pair A1, then the key value pair B2. And this can make it useful if you want to iterate over the contents of an array, of an object, sorry. All right. Do we have any questions about the built-in object methods? Again, you're not expected to have these memorized. You can always refer to the documentation or these slides if you forget how any of these work. So these last three are a little particular. You have to say object.keys, .values, or .entries, and then pass the object that you wish to check. Whereas the first one, you have the name of the object in the first, then dot has own property, or alternatively, and much simpler in my opinion, is the name of the key as a string in, and then the object you wish to check inside of. All right. And that's object methods and the object literal data type. Great. So I actually do have a session example I want to go over. In some of the examples, you'll see me using something called a spread syntax. That is particular to JavaScript. It's not critical that you know this in other languages or important in your fundamental understanding of programming and critical thinking. But I do think it's something you should at least be familiar with because I might use it from time to time. So it's just one syntax available in JavaScript that allows us to, as the name suggests, spread the contents of an array or an object. So I think it's easier to explain it through an example than anything else. So here I have a function that takes two arguments, arg1 and arg2, and it prints the two of them. So here I have an array that's called my args that has two arguments inside of them, hello and world. That's what I want to pass to the function. Instead of, like, there's one thing I could do. I could say my func, pass it my args the first one, then my args the second one. But instead of doing that, and imagine if I had 100 arguments, that'd be such a tedious thing to do. There's something called spreading, and that's like me taking the contents of this, copying it, and then pasting it inside of it. It's exactly what's going on in the background. It just takes it and it plops it inside, the exact contents of the array or object in question. So here you can see that if I give it my arg, it's going to say hello world. I can have my func run, and it should pass hello and world to arg1 and 2 respectively. And if I give that a run, you'll see that's true. Actually, let's ignore everything else for now, because I don't want to have too much stuff showing at the time being. So here, the array says hello world, and when passed to the function, it says hello space world. Additionally, one other thing I want to specify is that if you console log with a comma, that's equivalent to just concatenating a space in between. All right. So the next thing regarding spread is another use case for spread is how you can append to an array. So let's say I had the contents my args and I spread it. This is what it looks like using the 3 dots. This is called the spread operator. So I put it before the thing which I want to spread out. So I can take the contents of this array, and here it's like I can just place it in its place. So this is what the new array is going to look like. Hello world, and then I added a new thing at the end. So you can see how I can make a new array. I made a new array with the contents of the old array, and then put a little thing at the end, a new element. So you can use spread to append to an array, but typically you just want to use .push, because .push just takes the existing array and puts a new thing to it. But spreading in this way creates a brand new array and then adds something to the end. And that's more expensive and it's going to be a lot slower. But there might be certain cases where you want to create a new array. And we're going to go over such cases later on here. Before I go any further, are there any questions about the spread operator and how it works on arrays? No? All right. So here we have an object called descriptor, and its purpose is to describe the function. So here I see the function name is my func, the arg count is 0, and these are the arguments passed. Now, this is not quite right. It takes 2 arguments. So we should update that object. But if you wanted to change a specific thing in a descriptor, you could just say, descriptor dot arg count equals 2. Like I could update it using a dot notation or a bracket notation, as we've specified earlier. Oh, sorry, like that. But alternatively, and this is just one of many ways we can do it, which is again why I said it's not essential that you know spread syntax to do things in JavaScript. It just makes it a lot easier. Sometimes it can make things a lot cleaner. So here you can imagine I take the contents of this and I just replace this with that. And what it looks like is I've created a brand new object where now I've overwritten the old contents with these new things. So if I go here, you see I've taken the contents of descriptor in a new object, but I want to replace the existing args key with this new value of the my args array. And I also want to overwrite the existing arg count with 2. So what this would do is if it already existed, it would overwrite it. And if it didn't exist, it would create a new key value pair in this brand new object we've created. So you can use spread syntax to copy an object and make modifications to that new object if you so desire. All right, are there any questions about copying objects here? No? All right. There are 2 different kinds of copies, and you'll find this consistently in every programming language and every kind of system we utilize. There are shallow copies and deep copies. And a shallow copy is when I copy a reference to an existing data type, an existing thing. So let's say I have an object and I have a variable named my object, and it refers to this data somewhere in memory on the computer. I could say, I want to make a new variable and I want to say it equals this object. Instead of making a brand new copy of that object, it refers to the same object. So like I can do, it's the same rules with arrays. Here I can say I have an array x equals 1, 2, 3. I can say y equals x. And then I could say, I want to push 4 to x. So you would think that x is going to be 1, 2, 3, 4, and y is going to be 1, 2, 3. But no, they are both 1, 2, 3, 4 because they both refer to the same array. And that's, again, why we had to create the slice thing. I could say z equals y.slice. And that allows you to make a deep copy of the array. So instead of a shallow copy, a deep copy is when you create a brand new instance. You create a whole new thing that copies the contents of the other. So now I could say z.pop, and it gets rid of 4 from the end of the array. But x and y still have the 4 at the end because they refer to the same, and z refers to a brand new one that just happened to copy the contents at that time. So that's a distinction between shallow and deep copies. Now, when you use a spread to copy to make a brand new instance of an object, that's a shallow copy. It only copies one level deep. So here's an example of the shallow copy. If I give this a run here, actually, let's go over these examples first. Here I have my arrays with the smiley face added at the end, and it's still only printed hello world because it only wants 2 arguments. Here I created a new descriptor, and it has the contents of arg count 0 and then at this empty array, but I updated it with our args, my args, and the arg count 2, and it's printed the same, noting that my func is still the value of my function name. That didn't get changed at all because it copied the existing values of the descriptor. And here is our shallow copy. It looks exactly the same as this descriptor, but it's only copied one level deep. So strings and numbers are still going to be independent copies because they never refer to the same thing. That concept of shallow uncopies only applies to objects and arrays. So if I copy a value, like I can say x equals 3 and y equals 3, if I were to increment x by 1, y stays the same because shallow copies do not apply to individual numbers or strings. So here, this function name, if I were to change one of them with a shallow copy, it would not change in the other one. If I were to change the arg count, that's the exact same thing. Increasing this by 1 would not increase the former by 1. But if I were to have changed this array, it would change the other array because they're referring to the same array. So shallow copies of objects means any arrays or objects within that object would refer to the same kind of data. So here's an example. I can put a new thing in a shallow copy, like is copy equals true, and I print both the descriptor and the shallow copy. Give this a run. And because it's a different object, because I created a new object using these curly braces, new key value pairs do not actually come into the original object. It's just changes to the existing arrays that they're referring to that will be copied. So both objects refer to the same args array. So here I'm saying let's pop the last smiley face off the end of that args array. And what I should see is they both lack that now. So I give this a run, and you see that here there's no smiley face, and here there's no smiley face. So the change in one arg array happened to the other one. So as all objects and arrays within our spread, if I spread every single object and array within it the same way I did for the object at the highest level, and I know exactly how many objects and arrays are in there to however many depth I have to work with, then I can create a deep copy. So here, this is how I would do it. I would spread the descriptor, and then I also have to spread the args within it. So I create a brand new array referring to the values that were in the original array. And if there were any other arrays or objects within that array, I would have to deal with that as well. So here I want to push 6 to the end of the args in our deep copy, and we should not see it in the original descriptor. So if I give this a run, you'll see that's the case. Here our args are just hello world, and in the deep copy, 6 is at the very end. So that's how we would create a deep copy and shallow copies using the spread operator. Do we have any questions about the spread operator? Nope. All right. So now why don't we get started with some exercises? I think we should do a warm-up. There is a simple one called the right triangle, if I can find it here. And right after that, we will move into the review problem of remove zeros. All right, so this problem wants us to write a function that returns the area of a right triangle given its base and its height. And as you may or may not remember from geometry class, the area of a right triangle, being one with a 90-degree angle, is the half of its base times its height. So just create a function that returns the area of that triangle. And this, I'll give us a good 10 minutes to do this. I'm going to put this in the chat. All right. All right, so right triangle. To find the right triangle, to find the angle of any right triangle, it's half base times height. So before I even write the code for the solution, I might want to write some tests describing our desired behavior of this function. Say tests. So let's say I want, let's think of an example of base times height. Well, if we had a triangle with a base of size 2 and a height of size 2, that'd be 2 times 2 is 4. Divided by 2 is going to be 2. Okay. If we had 1 and 1, divided by 2, that's going to be 0.5. So immediately we know it needs to be able to return integers or floating points. So here I can say right triangle where the base is 2 and the height is 2. That needs to equal 2 times 2 is 4, divided by 2, that gives us 2. If we had, 1 and 1, that would have to give us 0.5. If we gave it a right triangle with negative sides, should that return a negative area? If we gave it a triangle with 0 base and height, should that return 0 area? Actually, yes, it should, but because we didn't tell it what to do in that kind of situation. But these are kinds of questions you would ask the person you're making the code for. And those are fair assumptions, assuming that you ever see a negative base or negative height in a triangle. But let's just use these tests as an example and write our code here. So we know we can take half, or we could just say 0.5, times the base times the height. And if I give this a run, I'll see they both return true. So again, you don't have to worry about casting between floating points or integers because in JavaScript, it's all one type, number. So you don't have to worry about things like that. You do have to worry about strict equals to ensure that the type is in fact the correct type though. So if I was to try and multiply some kind of string, it would not work. Oh, it shouldn't work. If I print this out. Oh, that's right. An interesting thing that a lot of people forget is that when you multiply a string with a number, you get a number. Yeah, but if I was to, subtract, if I had 1 minus 1, that gives me 0. 1 plus 1 as a string gives me a string. So it's addition of strings and numbers that resolve strings, but the multiplication or subtraction of them will give us numbers. So just got to be careful that we don't accidentally throw in the wrong type, but in this case, it wouldn't have really mattered. All right. I think that was a good warm up. Do we have any questions about the right triangle problem? No? All right. So now we can get to our review from the last session on remove zeros. Remove zeros. So we need to write a function that returns a number with all the zeros removed from it. We already attempted this problem yesterday, so today we're just going to go over the solution and not break up and do these individually. So we're going to do this from scratch. We already do have the solutions on Slack, and I have two solutions posted, one that uses the filter method and one that uses a simple for loop. So the first thing we can think of is if I was to convert this number that's given to me as a string, then I'd be able to go through each one of them one at a time. So if I go here and I'm given a large number, x equals this big number here, 101,921. I can't really iterate over each digit in that number. And to clarify, a number is just, any number. It can have as many, it can be as long as you want it to be. But a digit is each of these individual 1, 0, 1, 9, 2. There are values between 0 and 9 inclusive. So I can't iterate over those if it's a number. I can say, I want to mod it by 10. That gives me the last one. I can take the number and I can divide it by 10. And now I can, mod it again by 10 to get the next value. So there, and then floor it. So I can keep going one at a time to get values on a number. But there's a much easier and less mathematically inclined solution to this problem. I can just take x and convert it to a string. Well, actually, I want to multiply it by 10 first, because I divided it by 10 right there. So I have this number, and I want to convert it to a string. So x equals x dot toString. Because this is a non-mutating function, I have to assign it back into x. So now I have x as a string. And if I was to iterate over it, I can show you here, for my digit d of this number x, I want a console.log d. And you see it went over each digit one at a time. So now I can go through each of them one at a time and say, does it equal 0? If it does, don't add it into our new number. And we can build that number by taking each of these digits, which are strings here, and place them into a new string that I add stuff to. So here I have x, right? I can add stuff to an array using concat or plus. So if I say x plus, a, I put a at the end of that. So I can add to an array and I can, to a string, sorry, and I can assign to them by using the assign operator. So I can build these strings, or in this case, I could build numbers by adding characters 0 through 9, and then casting it back down to a number. So that's the algorithm of the for loop. Was there anything that wasn't clear about that algorithm? Anyone need any more explanation on that? No. I'm gonna go over it again by actually implementing it. So here, I have to return a new number because I'm going to be adding the values that I want to it. So I'm going to call that res, short for result. So I'm going to say let res equal this empty string here. I can say, and I also need to have the number as a string to actually iterate over. So I can say for a digit d of number dot toString. So I'm iterating over it as a string. I can say if this digit d does not equal 0, then I can add it to res. So res plus equals d. All right. And after I've gone through that entire number, I will only have them as as with all the zeros gone, because every instance where it was D was 0 was just ignored in the if statement, and it went to the next digit of the number, sorry. So after that's done, I have res, but it's a string, so I need to convert it back to a number so I can return the number cast on the result. So let's take these 2 examples here. Give this a run, and they both return true. So 1001 does return 11. This long number returns the same number with all the zeros gone. That zero is not there, that zero is not there, and the one after it is not there. All right. Are there any questions about this implementation to remove zeros?
Yeah, I can explain the let res equals the quotation marks again. I don't understand why you did that.
Okay. Res is a string with nothing inside of it right now, right? So if I were to make a string like res equals empty string, that's just it is a string. It just has nothing in it yet, and I could put something in it like hello, and now the string res has the value hello. I can then add to it, a space, and then it has a space at the end. The idea is that instead of adding arbitrary things, I could add to it numbers, so I can build it one at a time. So res plus equals 1, res plus equals 5, res plus equals 3. And you see it gets one bigger every single time, but it starts empty. But it is still a string, even though it is empty. All right, does that answer your question?
Yeah.
All right. Are there any other questions about remove zeros?
Where did we define, or how do we define D?
D is a variable that I made just as much as res. Actually, I should say let D of number.toString. They're both, it's actually not required in JavaScript in a for loop when you're declaring the iterator to say let. It's just, I think it's a good practice because it makes it obvious that this is a variable that I'm declaring. I could have just as easily called this anything else. I could have called it digit. I chose D to represent the iterator because D stands for digit, and a digit is the individual number, the individual single digit. It's a number in the number. Yeah. So to answer your question, I made it using a for of loop.
Okay. Thank you.
Mm-hmm. Are there any other questions? There was another solution that I provided earlier using the filter method. The filter method can be applied to any array prototype. So that means I would have to convert it to a string, convert it to an array, then use filter on that array, convert that array back into a string, and then convert it into a number. All right. So let's go over that second solution here. So here I want to make an array of numbers as characters. So again, I have some number. I'm just going to say num equals this big number here. And I can say num equals num.toString to make it a string version of the number, right? But now I want to make it an array of individual digits. So I can say I want to split this string into an array, and I can split it on any condition, like when there's 2 1s together, split it there. But I'm going to say I want to split it anywhere that it can be split. So that means on the condition that an empty string exists, which is on every character. So if I do that, it just creates an array of each of the characters. So now I have this array, and that means I'm able to apply the filter method to it. So I can say .filter, and I want to say keep it on the condition that the following function returns true. So this function I'm going to create takes a digit D, and it's going to return whether or not that digit is equal to 0. So if it does not equal 0, keep it. If it is 0, remove it from the array. And just like that, it gave me an array with all the zeros in it removed. But that's not what I wanted as a number, not an array of strings. By the way, a little nomenclature here. Usually we use the word character to refer to a string of length 1. But in JavaScript, there is no distinction between these types, so it's equally appropriate to call them strings. All right, so now I want to join them together, and I could show you a different condition. Let's say I wanted to join every time a 1 was found, or every time there was 2 1s found. Actually, yeah, that doesn't, that just makes it longer because it has to append more 1s to join them together. This is what's separating each of them apart. So if I put a comma here, you'd see there's a 1 between there's a comma between every single one of them. I could put a lot of spaces in between them, and it makes a string with all those spaces between each element. I want them to join together with nothing separating them. So that's why I give it the empty string to represent nothing. All right, and I still need to convert this into a number. So realistically, I could make this a 1-line function if I really wanted to. I usually choose not to because it makes it a little bit easier to read. So I could say const remove zeros, which takes a number, returns the following. It's going to take number.split on every single character, dot filter d, where d does not equal 0, because that is what we're looking for, all the ones that are non-zero, and join it with nothing separating them, and cast it to a number. And if I give this a run, oh, right, I have to convert it to a string before I split it. See, you can't apply split on a number because it's a method that belongs to strings. So that works perfectly. A little ugly though. That's why it might be helpful to break this into multiple lines. So here I could say const numArray equals number.toString. So convert it into a string and then split it up into an array of characters. Then I can say my numArray, I want to filter it on the condition that none of the individual characters within it are equal to 0. And then I want to join that again with nothing separating it. And I want to return this cast as a number. So I think that's a little easier to read. Whether you want to do a 1-line solution or break it into multiple lines for better readability is just a matter of preference. Are there any questions about this, this alternative solution? No? All right, so moving on from the review problem, we can start some new problems. I have a problem here called the last 4 numbers of your social, and that's an arrays problem. So last 4 of social. Oh, I should probably erase this. There we go. All right, so we need to write a function that takes in a number, which represents your social security number, and returns the last 4 digits of that number as a string. So there's various methods we can use here that might help us. We have toString, split, slice, and join. Again, if you have any concerns about how these work, you can always refer to the documentation for them. So I can look up here JavaScript.toString. Like I'm wondering how that works. Well, look, I have it here. There's a lot of versions on the Mozilla one. Here you can apply it to an object, you can apply it to a number, you can apply it to a string. So it's showing you where this method is applicable. So here, if I wanted to apply toString to a number, this is what the behavior of it would be. So if you want to find any examples of how any of these work, in this case, we're using the number.prototype.toString because it's applied to a number, but you also might want to use split on that string, slice on that string, or join on that string to convert an array back into a string. And remember, to convert to a number, you use number and then put the whole thing in parentheses. All right. I'm going to send you the link to this problem, and I'm going to give us 15 minutes to solve it. Can you zoom in on your screen a little bit? Yeah, absolutely. Is that better? All right. Great. Okay. So here's the problem. We have 15 minutes. One, 5, 0, 0. Oh, a little long. 1, 5, 0, 0. Set and start. All right, the last 4 digits of your social security number as a string. So let's take these examples here, and we're going to make some tests out of these. Go to index.js. Oop, that's not how you spell tests. There you go. Gonna select these. Strict equality on a string. So this ensures that it is going to return a string. Console.log. And there is a reason why we want it to be a string. It's because if a number begins with a 0, that 0 is just going to be removed. So here you see 0769, for example. If I have a number 0769, it's just going to be 769. It gets rid of the prepending 0. But if I had a string 0769, it keeps it. So if we had the last 4 digits like 0000, it would just give you 10. So it can cut off up to 3 digits, which is not what we want. We want to return exactly 4, so we have to return it as a string. So that's the reason why. Semicolons aren't necessary, just strongly recommended. All right, so here we want the last 4 digits of your social security. We have a number of methods to choose from, and naturally there's going to be more than one solution to this problem, so my solution might be different from yours. The first thing we want to do is convert it to a string so we can manipulate it by digits. So let's say here I want to just say string of my social security is just going to be social security dot toString. Okay. Didn't have to make a variable for it, just think it'd make the code a little cleaner. Then we have something called slice, which can be used to extract a certain selection from it. So let's say here I have a string, 43231232213. If I want to slice it, say I want the first 4 digits, I can give it a 4. Yeah, if I wanted the digits from 4 through 7, 1, 2, 3, 4, and then I have 5, 6, 7, and that leaves you with 3, 2, 1. So you can say a specific selection of it. So let's just go to the documentation here to show you what that would look like. Here I can say there's an array slice and a string slice. Let's look at the string slice. You get the beginning index and the end index, or just the beginning index. So the interesting thing about slices is you can actually pass negative indices. So if I say slice -1, it gives me the last digit of the string. If I say -2, it gives me the last 2 digits of the string. -4, the last 4 digits of the string. So that solution is actually pretty simple. Return the input as a string, dot slice -4, and that will give you the last 4 digits of the social security number. Alternatively, let's say we didn't know about reverse indices. How could we get the last 4? Well, one thing we could do is we could reverse it. Let's say I had a number 1, 2, 3, 4, 5, which means I want to return 2, 3, 4, 5, the last 4 digits. I can actually convert it to an array, then reverse the contents of the array. Because if I try to reverse the string, that's not a thing. But I can convert it into an array. I can reverse it. Then I can say I want to slice the first 4 digits of that array, because slice can exist on an array as well. Oh. So that gets you the first 4 digits. Remember, the rules for them are different because they're actually different methods. One applies to a string, one applies to an array. So here I have to provide the beginning index. And then I say I want to join it back into a string, but that's the results backwards, 5, 4, 3, 2. I wanted 2, 3, 4, 5. So I can actually reverse it again, 2, 3, 4, 5, and then join it. And that can give you 2, 3, 4, 5. So if you weren't aware of negative indices, you may come to a solution like this, which still works, but I think this is a lot cleaner and a lot more efficient. All right, do we have any questions about this solution?
Is there any issue with using last 4 as the variable name?
No. There's no issue. Oh, you mean within the function?
Yes.
Okay. That might cause an issue. Let's give it a try. Let's say I want to here make a. I expect it would. It might complain because otherwise you can't make recursive calls to the same function. You can't refer to that same function because you rewrote the variable. So here I could say, let last 4 equals, 1, 2, 3, 4. And then I try to say, hey, you mind console logging that number for me, please? I don't know if it'll let you do that because last 4 has already been declared. But let's let's find out. I'll give it a run. It actually does override it just fine. And if I got rid of the let, it'd probably refer to the existing declaration last 4. So
yeah, that's what I did. I didn't do the let. I just said like what you did with the social security variable name. I just put last 4 dot toString, etc.
Yeah. So using let, it does work. And if I get rid of that 1, 2, 3, 4 and I try to print it to you, you would see that it does in fact return a function because that is the function it's referring to. You just overwrote this with a local variable last 4, which has this value. That's what you do. So last 4 is actually made as a variable at the outermost scope. When I say let last 4 equals 1, 2, 3, 4, I'm making a local variable which overrides this global variable here.
Okay.
But if I don't do that, it's not aware of last 4 because it doesn't. You can't overwrite a global with a local like that. It doesn't work that way. Evidently, it complains that it doesn't exist. Last 4 is not a function. If I tried to here say let ASDF, and here I say ASDF equals 1, 2, 3, 4, would that work? Yeah, it does. Well, I'm not printing it, but you get the idea. When I already have a function that's been declared at a global scope and I try to override it, no, that does not work, evidently. I would avoid naming variables within the function the same name as the function, just because it's probably going to cause a lot of confusion. You might try to call it digits or a result RES. All right, is there any other questions? No. All right. So I'm just going to delete this solution here. So that's last 4. The next one we have is current grade, and this one will utilize objects, which we've learned about today. Well, we've already been familiar with objects, but that was the focus of today's slides. So we need to write a method that takes in a student object with attributes GPA as a number. So here it has, it takes in its first argument as an object. This one can be a GPA with the value, which is a number, and a grade level as a number as well. So what grade they are in, 1 through 12. They're in high school, or they're in school. This method should update their students' GPA to include the change and to increase their grade level by 1 year. So it's like, imagine I have a student and I have their current grade and GPA, and I'm saying that after 1 year, their GPA increased by 0.3 or decreased by 0.6, and I can give it a positive or a negative number to indicate whether it's decreased or increased. So the next year after we finish the current grade, they're now in grade 11 and their GPA is 2.8. It went up by 0.3 grade points. So it returns an updated student object. All right. This message changed to increase again. So it returns the updated student object. So it is fair to assume that it's referring to the same object. It didn't say return a new student object, it's returning the updated student object. So that's really a question of how you interpret the written question. But I'm going to just clarify that if it refers to the same object, that is perfectly acceptable. You don't have to create a new object for this problem. All right, are there any other questions about what this problem is asking? Nope. All right, if that's the case, I am going to share this in the chat and we'll have 15 minutes to work on it. Actually, it's been an hour and 24 minutes. After this problem, take a 10-minute break. So I'm going to give us 15 minutes. We are going to solve the problem and we'll take a 15-minute break. That sound good to everyone? All right. So starting now. I should close this one out. Did I erase this last 4 of social? Yep, I did. All right, so current grade. Like I said, you're allowed to refer to the same object. I'm going to show you how to do it with and without the new object, but let's go with the intended solution first. These are some good solutions here. Hold on a second. I just want to copy these as tests. Oh, that's not what I wanted to do. Okay. Here. It's starting to slow down a little bit. I don't know why. It seems the longer the session goes, the slower my computer becomes. So the first one, we have the student object in question, and then we have the improvements on that student object. So if we're allowed to just change the existing student object and return that object, then it's really just a matter of saying student.GPA is going to be incremented by the amount specified in improvement. So if it was 2.5, I add 0.3 to it, and now it's 2.8. If it was 4.0, I add negative 0.6, and it becomes 3.4. And as for the grade itself, it always increases by 1 because we just finished one grade. So I can say student.grade is incremented by 1. Sorry. Great. Oh, we didn't have any conditions specified for if they're at grade 12. I guess we can just say they're at grade 13 and let that signify first year of college. Or actually in Quebec, I believe they have 13 grade levels, but it's besides the point. And at the end, we just need to return the student object. Oh, if I can spell. I can give this a run. And ooh, we did not get the expected result. Why is that? Let's actually just print. Did I? Oh, I have to close the. No, I did. I closed the call correctly. Let's just console log this first one to see what we did wrong. I close it off. And the grade went from 10 to 11, and the GPA became 2.8. So this is the oh, do you know what's wrong? We can't just compare objects this way. Remember, we talked about object comparisons earlier? So we're just going to print them out to verify that it is returning the correct thing. We did make a function to compare objects earlier. I'm just not going to import it here because it's going to be a bit of a pain. If you wanted to write tests, you'd have to make an object comparison function. So I can go run, and I see it's 11 and 2.8. And the grade for the second one is 7, which is 1 more than 6. And the GPA is 3.4, which is 0.6 less than 4. So this is returning the correct object type. But I do want to clarify that these are, in fact, referring to the same objects that was passed into it. So if I were to have this object here, this is a mutating function. I could say, my student, and I could not declare it as const because this is trying to mutate it inside of here. So I'd have to say, let my student equal this, and then I would pass this my student as an object. So it refers to the same one. It will mutate it. And if I actually if I try to console log my student, I will see the change has actually occurred on the object itself, not just on the returned object. So you see they both have the changes after this function was called because it is a mutating function. If I wanted to make a non-mutating function, I would have to create a new object. So I could do that by copying the contents of the student and then making the increments on this copy, or alternatively making it within the copy using a spread notation. So there actually is something in JavaScript called new object if I wanted to create a new object. But the spread notation is an alternative way to do it. Let's go in here. Yeah, okay. So one thing I could do is I could just return a brand new object I create. Again, this is not what I asked you to do. This is just a question of how would I create a non-mutating version of this function. I can return a brand new object that contains grade, which is the student.gpa, plus the improvement. See, no equals was used, so there's no assignment occurring, and therefore it is non-mutating. Oh yeah, that's right. It's in an object, so I just use a comma. And then I have the GPA. So GPA can be, oh, my bad. This should say student.grade plus improvement. And here I have the student. Nope, that it is in fact the, yeah, this should say GPA. I'm sorry. The GPA is the current student's grade plus the improvement. And the grade is just incremented by 1. So student.gpa plus improvement, grade is student.grade plus 1. And the order does matter because that changes the order in which the object has the key value pairings, but it depends on how we define comparisons and equalities in objects. So if I return this, it's going to give the same results, 11, 2.8. but the difference is the original object was not modified. So this stayed 10, 2.5. And we got 7.3 for the expected result. We could have done this using a spread just as easily. And I could show what that would look like. Actually, it'd pretty much look exactly the same, except I would spread student on it. But the thing is, that's only helpful if I had, let's say there were multiple key value pairs in here besides just grade and GPA, and I only wanted to change grade and GPA. I could just spread everything to copy everything in it as a shallow copy, and then modify the things that needed to be modified. All right, so that's how I would create a non-mutating version, by creating a new object. But that is not what I asked you to do. All you had to do was increase the GPA by the improvement, and the grade has to increase by 1, and then you return the student. Oh, and this should have an opening bracket. All right, are there any questions about this problem?
Is it okay if I added a new parameter to the function? I added GPA. I don't know. It worked, so I don't know if that's acceptable.
You mean you had student improvement and then a third parameter called GPA?
Yes.
Or
actually, GPA was the second parameter. Improvement was the last one.
I'm going to say that that's not okay, because if I were to have a program that used this and had an expected function signature, it would break with that code, because it's not. It expects 2 arguments and you gave it 3, so that wouldn't work. I mean, you could make a solution that takes 3, but evidently 2 is all that's required, because all the information about the student's grades and GPA exists within the student object.
Okay.
All right. Are there any other questions? No. All right. So that's the current grade problem. We can move on to hot potato, which is a types problem. Oh, I should probably erase this. Great. Right. Actually, before we move on, why don't we take a 10-minute break? And I will see you on, at 55. Let me just go back here. Put a countdown for 10 minutes. And I will see you then, and then we can start the next problem. Yeah, sorry, I forgot to press record for this problem. Just to recap what I just said, the hot potato problem will require you to pass a potato from one student to another as though they were in a circle. Oh, so when it gets to the last student, it goes back to the first one. And we can do that using the modulus operator if we are to do this without any loops. So if I give it 4 mod 3 will tell me that it went around once and then had a remainder of 1. So using remainders, this property of remainders, where it always goes back to 0 remainder when it has a perfect whole number that goes into the division, we're able to recount this kind of loop, which is perfect for going in circles. All right, so I'm going to give us 15 minutes to work on this problem. Let me share the link with you guys. All right, and I will see you in 15 minutes. Record. All right. So first, before we start working on the problem, let's write down our tests of our expected behavior for the potato function. So the potato function, we're given the number of turns, which is how many times we've passed it to the right, starting from student 2. So let's start with a naive approach. Actually, I just want to, let's say I just want to console.log potato 0 and potato 2. And I kind of want just to see what the outputs look like. So we know we have to start from student 2, right? So imagine that the output was 0. The expected response would be 2, right? But if, let's say, I then moved 2 to the right, then I'd want to add that number of turns moved to the right, because that's how much the student has increased, and student number is actually increasing as we move to the right. So when I move 1 to the right from student 2, it became student 3. So we take the current student and add the number of turns. So you'll find that for these examples, that actually works. If I give this a run, we're going to see 2 and 4. It did work, because if I had student 2 and he passes to the guy on his right, that's 1 turn. He's a student 3. 1 more time, he's a student 4. But what happens if we went 3 to the right? Well, it's going to say student 5, and student 5 doesn't exist. It needs to go back to student 0. So what I need to do is check, am I at student 5? If I am, then go back to 0. And this is exactly what modulus does. If I said mod the solution by 5, so let's say here I had, that would say that if the number is divisible by 5, it goes to 0. So again, I can say what's 1 divided by 5? That's, 1/5. So the modulus operation is going to return 1, because there's a remainder of 1. 2 over 5, that's 2/5, 3/5, 4/5. 5/5 is just 1. So it's 1 remainder 0, 1 and 0/5. So it's going to go 0. Then I can say, 6/5. That's going to have 1 remainder. 7/5. So every time it makes a full loop around. And you can think of the equivalence of catching up to the nearest whole, every multiple of 5. You can think of it as making 1 whole rotation around that student circle, because it's made a multiple number of the students in that circle. In this case, 5 students. 1, 2, 3, 4, 5. We're back where we started. Then every time we want to go back to 0, then increment over. And that's exactly what modulus does. But we're going to start with student 2 and increment over the number of turns. And all I have to do is take that result and mod it by the number of students, which is 5. So now that actually goes back to 0, and we can run our tests. And we see that they all return true. All right, are there any questions about this problem? Nope. All right. So that is hot potato. Moving on to our next problem. That is initials, arrays, and loops. All right. All right. So this problem says, imagine that we have a function that takes in our name. So that can be Elon Musk, Michael Jordan, Michael Gary Scott, and it will return your initials. So Michael Jordan's initials are MJ, Elon Musk's are EL, Michael Gary Scott's are MGS. And notice that it does have to be capitalized. So even if the name itself is in lowercase, we will get the uppercase result. All right. Are there any questions about what this problem is asking us to do? All right. So you are allowed to use loops for this, although you don't have to. You might also benefit immensely from the split array method. It's not required, but it would make this problem a lot easier. All right. If there are no questions about this problem, I will post this link in the chat. All the second test EL. Yeah, the second test should return EL. That's right. Oh no, EM. Sorry, I don't know why it says EL. It should say EM. Elon Musk, Michael Jordan, Michael Gary Scott. Great. All right. If there are no other questions, the link for the initials, arrays, and loops problem. We have 15 minutes to work on it. I'll see you then. All right. So looking at this initials problem, we have to take the name, which is given as one string with spaces separating each name, and convert it into an all uppercase, string containing the initials. So if there were 3 words, it's going to be 3 initials. 2 words, it's going to be 2. So let's take a look at, first we're going to make the tests for this right here. Oh, if I can spell it, tests. And I have to make this in JavaScript. So we want a strict equals comparison. We're going to say console.log. All right, so there are our tests. So let's just think out loud in the console here. Let's say I had a name like, well, Michael Jordan is a good name here. And we want to split this string into an array so we can operate on it. Now, there is the split operation, and that allows us to split on a certain condition. Before, we've seen splitting on an empty string, which breaks it into an array of individual characters. And it's weird. Dot split. Yeah, there you go. So that makes it an array of individual characters. I don't want to split on every time. I want to split whenever we see a space. Like I could split on, let's say, just to give you an example, if I split on an I would get one with an M and the rest would be Kyle Jordan. See? But so it removes the thing that you split on. If I were to split on a space, it would remove the space and leave me with Michael and Jordan respectively. And no matter how many names I had, as long as each name was separated by a space, this would work. Okay. Then one thing I could do is I could say I could run over a for loop and say collect the first character of each string. And I can do this by indexing that string, just like I would an array. So here I have a string Michael. And I say I want to get the first character in that. 0. I can get the first, the second, the third. This is the same way that I would collect elements of an array. I can collect elements of a string. So I don't have to convert the string into an array and index it. I can index the string directly. But I want to do that for every single one of them. Now, I could do a for loop, but alternatively, I could use a mapping. And what a mapping does is it does the same thing a for loop would do, but replaces each thing in that array with the result of my map. And we've discussed mapping before. So here I give it a function, and let's say I want it to take a name, and then I want it to return the first letter of that name. So it's going to go for Michael and replace it with M. Jordan, it's going to replace it with J. But that's not enough. I want it to be an uppercase version of whatever that letter is. And that leaves me with M and J, but I still need to join it together. So I have string, and that gives me the initials NJ. So now we've gone over the entire algorithm. We actually made the program in the process, but we can now do it here. A one-line solution is perfectly acceptable. Some people might prefer that you split it over multiple so it's easier to read. Depends on how long that one-line solution is. So here I could make an array and Like I could say name array equals full name dot split. You might want to make it uppercase here, or you might want to make it uppercase when you're returning the whole thing, or make it uppercase on each individual letter that's being checked. So there's a number of different places where I could have done that. Actually, why don't I show you the solution with the for loop, because I haven't shown you that yet. So here I have the name array, and here I can have my result, which is an empty string, which I'm going to add the initials to one at a time. I can say for name of the name array, and actually I'm only referring to it here, so I could just plop it right here, but in any case, I have this constant, so let's use it. Name of the name array. I can say to the result, I wish to add the name's first letter, and I could put it to uppercase. Alternatively, I could return the result made into uppercase. So again, there's lots of places I can do it before I return. And if I run this, you'll see that it works for all of them. Michael Jordan returns MJ, Elon Musk returns EM, and Michael Gary Scott returns MGS. So that's a solution with the for loop. And if I wanted to do it using a mapping, I could just as easily have gone here without having to save a variable, res, and adding to it one at a time. I can just replace each value in this array that I build. So, and it's actually, if I'm not mistaken, mapping is a non-mutative thing. So here I can say const x equals 1, 2, 3, and I could say x dot map, take some element and returns I plus 1. That's allowed because it didn't actually change x. So mapping is non-mutative but returns a new array. So I could do this on a constant. So now I can say I want to return my name array dot map, and here I have a name, and I want to return the first on it to uppercase, which then needs to be joined into a single string. Give that a run, and that works just as well. So that's two solutions to the name initials problem, one using a map and one using a for loop. Do we have any questions for this problem? No? All right. So let's move on to the next problem and our last one for today. That is going to be a legal word. And I should probably delete this right here. All right, so a legal word needs to take a function that takes in a sentence and an illegal word, which is a word that we do not want in that sentence. I need to identify that that word has occurred. So it returns a Boolean indicating whether or not the sentence contains this illegal word. And capitalization should not matter. So here I say hello world, hello there. And the question is our illegal word fudge in there? False, no it isn't. But I didn't say fudge. Fudge is in there, it's right there, it returns true. Similarly, if I had capitalized the fudge here or the fudge in here, it shouldn't have mattered. It would return true either way. Are there any questions as to what this problem is asking us? All right, it's 6:45. How about I give us 10 minutes to work on this problem so we have 5 minutes to work on the solution? Are there any questions about this problem? Nope. All right, let's put this in the chat. And I will see you in 10 minutes. We don't have a lot of time, so I'm going to kind of rush through the solution a little bit so I can focus on any questions you might have. So first and foremost, we know that anything that happens in the first, they have to be the same case. So you can convert them both to uppercase or both to lowercase. So if this is uppercase and this is lowercase, or this is uppercase and that's lowercase, either way, they're both going to be converted to the same case. So the comparisons are going to be valid. Comparing Booleans like this is actually a really bad idea. I'd rather just take the negation of this and get rid of this whole equals true thing, because a Boolean equaling true is, you know, it's either true or it isn't. So there you go. So here I have my illegal code word. I have a sentence and a word to check if the word is in it. Now, JavaScript doesn't use the in thing like we did for objects. They have something else. So if I actually look it up, what's it called again? I think it's contains. Is it, let's just see, contains, or for string. You look it up and you'll see that exact method. It's called includes. And it checks to see if that word exists in the string. If it didn't exist, by the way, we could have split it into spaces and then checked for an instance and gone over it with a for loop or something. But it doesn't have include, so we can use that. So I can return is the word in the sentence. So I can say sentence, and I can convert them all to lowercase. So we could have done uppercase just as easily. To lowercase dot includes the word, which is also brought to lowercase. And if it is, then it's going to say true. Otherwise, it's going to say false. I give this a run, and yeah, it passes all the tests. Right, do we have any questions? No questions? All right. With that being said, I guess you guys can get going 2 minutes early. I will post the recordings in a minute, or as soon as possible. All right, I'll see you all on Tuesday, because this week is Monday, Tuesday, Wednesday, instead of Monday, Wednesday, Thursday. All right.